Alright, sorry about that, guys. Thanks for being patient with me and jumping over to the second video here. So as I was saying, hopefully you have this table copied into your notes now, and we can move on to example 5, which is asking us to use those properties and those values that we just came up with. So part A here says to take the tangent of 60 minus the tangent of 30. Well, if you go back and look at that table, the tangent of 60 was the square root of 3 minus, and hold on, let me get my pen here, minus the tangent of 30, which is the square root of 3 over 3. Well, in order to subtract these, we need to have common denominators. So we actually need to have this be over 3, which means we need to multiply the numerator by 3 also. So now we have 3 square root of 3 minus 1 square root of 3, which is 2 square root of 3 over 3. Okay. In example B, we have 2 times the sine of pi over 6, which if you look back at your table is 1/2, it's the sine of 30, times the cosine of pi over 6, which is the cosine of 30, which is root 3 over 2. I can actually put this 2 over 1. So I'm going to multiply my numerators together, and I get 2 square root of 3 over 4, which I can simplify to square root of 3 over 2. Okay? Alright, let's try example 5, skill practice. So, cotangent of 60, if I look at my table, the cotangent of 60 is square root of 3 over 3 minus the cotangent of 30, and the cotangent of 30 is the square root of 3. So again, I need common denominators, so I'm going to go ahead and multiply the second by 3 over 3, which is a special case of 1, right? So 1 square root of 3 minus 3 square root of 3 is going to be negative 2 square root of 3 all over 3. Okay? And over here in B, I'm going to write a parenthesis here. Sine of pi over 3 is square root of 3 over 2 times cosine of pi over 6, which is the square root of 3 over 2, because they're complements, plus cosine of pi over 3 is 1/2 times the sine of pi over 6. Again, those are complements, so it's going to be another 1/2. So root 3 over 2 times root 3 over 2 is going to be 3 over 2 plus 1/2 times 1/2 is 1/4. Oops, and I did make a mistake here. Root 3 times root 3 is 3. 2 times 2 down here is 4. So 3/4 plus 1/4 is 4/4, which is just 1. Okay? Alright, these next couple of tables here, again, you might want to take a minute to pause the video and copy these identities into your notes. I don't have a sheet with all of them on there for you yet, and I'm not sure when I will have one ready for you. So for now, you might want to take some time to copy these. Really, the reciprocal identities are just saying that, you know, sine is 1 over the cosecant, and the cosecant is 1 over sine. We already know that. Secant is 1 over cosine. Cosine is 1 over secant. Cotangent is 1 over tangent. Tangent is 1 over cotangent. We know that, okay? The new ones are coming from right here. Tangent is the sine over cosine, so cotangent is the cosine over sine. And these Pythagorean identities. Sine squared plus cosine squared equals 1. And then the following two are just derivations of that. So tangent squared plus 1 is secant squared, and 1 plus cotangent squared is cosecant squared. Okay? So we're going to be using those in a later section, but you are going to need to know those properties or those identities. So you might want to take a second to write those down. And then we also have the cofunction identities. So basically what these are saying is that sine and cosine go together. They are cofunctions because when you take the sine of one angle, it's the same as taking the cosine of its complement. So if you think about like 30 and 60, the sine of 30 is the cosine of 60 because 30 and 60 are complementary angles. Same thing with tangent and cotangent. So the tangent of one angle is the cotangent of its complement. And then same thing with secant and cosecant. The cosecant of one angle is the secant of its complement. So we can use those cofunctions to help us simplify um, expressions. So if I look here, I have part A. It says the cotangent of 15 equals 2 plus the square root of 3. And it's asking me to find a cofunction. Well, the cofunction that goes with cotangent is tangent. And so the cotangent of 15 is going to be the tangent of its complement, which is 90 minus 15. So this is going to be the tangent of 75 is going to equal 2 plus square root of 3. And that's really all it's asking us to do, is just identify what that cofunction is. And it's the cofunction of the complement. Okay? So over here in B, we have the cosine. Well, cosine's cofunction is sine. And what's the complement to pi over 6? Well, it's 90 minus pi over 6. But what is 90 in radians? It's pi over 2 minus pi over 6. Well, what is that? You can either know that pi over 6 is 30 degrees, so 90 minus 30 is 60, which is pi over 3. So it's really pi over 3. Or you can go ahead and actually get common denominators. So pi over 2 is, how do we write that with, a denominator of 6? Well, 3 pi over 6, right? So 3 pi over 6 minus pi over 6 is 2 pi over 6, which is just pi over 3. So that's kind of the long way of doing it, but you should really start to know pi over, pi is 180. Pi over 2 then is 90. Pi over 4 is 45. Pi over 6 is 30. Pi over 3 is 30. Those ones you really, really should know just off the top of your head to help you do problems like this. Okay? So looking at this one, what is the cofunction to tangent? Well, the cofunction of tangent is cotangent. And we need the complement of 22.5, so I'm going to subtract it from 90, and I'll get the cotangent of 67.5 is equal to the square root of 2 minus 1. Okay? Secant, the cofunction for secant is cosecant of 90 in radians, which is pi over 2 minus pi over 3, which now hopefully you should know is pi over 6, right? 90 minus 60 is 30, equals 2. Okay? Perfect. All right. Angles of elevation and depression. Hopefully this stuff is just review from geometry, right? Angle of depression goes from a horizontal sight line down, and an angle of elevation goes from a horizontal sight line up. The important part to remember is that they both start at this horizontal sight line. Okay? So here's our first example. it says palm trees are easy to transplant relative to similarly sized broad-leaved trees. At one tree farm, palm trees are harvested once they reach a height of 20 feet. Key feature. Okay? Suppose a farm worker determines that the distance along the ground from his position to the base of the palm tree is 22 feet. He then uses an instrument called a clinometer, held at eye level 6 feet, at an eye level of 6 feet, to measure the angle of elevation to the top of the tree to be 30.2 degrees. Is the tree tall enough to harvest? So we want to know, is this total height here at least 20 feet? Well, we're going to start by using this right triangle to solve for this value, x, because then we can add this 6 feet to it. So how are we going to do that? Well, using my 30.2, x is the opposite side. I also know the adjacent side is 22. So that's going to be tangent, opposite and adjacent, right? So tangent of my angle 30.2 equals opposite x over adjacent 22. And I'm going to set this up as a proportion, cross multiply, right? So x is 22 times the tangent of 30.2. Oops, not 302.2, but just 30.2. Okay? Now, make sure your calculator is in degrees for this because 30.2 is a degree measurement. So go ahead and do 22 times the tangent of 30.2, and you should get 12.8 feet. Well, my total height then is the 12.8 feet plus the 6-foot height of the man. Okay, so that gives me a total tree height of 18.6 feet, which isn't quite 20 feet. So this tree is not ready to be harvested. Okay? All right, let's try another one like that. So suppose that a farm worker determines the distance along the ground from her position to the tree is 16 feet. She measures the angle of elevation at an eye level of 5 feet to be 45.9. So we want to know the total height of the tree. Let's start by solving for x. Again, we're using tangent of 45.9 equals opposite x over adjacent 16. Cross multiply, x is 16 times the tangent of 45.9, which we get to be 16.5 feet. So that makes the total height of the tree 16.5 plus 5, which is 21.5 feet. And since that is more than 20, that means yes, this tree is ready to be harvested. Okay? 2 more here. This one is talking about an angle of depression right here from this horizontal sight line. This is a pilot flying an airplane at an altitude of 1 mile, so that's height, 1 mile of height. Sights a point at the end of a runway. The angle of depression is 3 degrees. What is the distance d from the plane to the point on the runway? So that happens to be the hypotenuse of the right triangle. We have the side opposite. So since we're dealing with the opposite side and we want the hypotenuse, opposite and hypotenuse means we're using sine of 3 degrees equals opposite 1 over hypotenuse d. Now, because the variable is at the bottom, this is going to be a little different. So when I cross multiply, 1 times 1 is 1 equals d times the sine of 3. How do I solve for d? Divide off the sine of 3. So d is 1 divided by the sine of 3. So go ahead and put that in your calculator. And you should get 19.1 miles. Okay? All right, last problem for today, you guys. A 15-foot ladder is leaning against a wall. Okay, here's my ladder. At an angle of 62 degrees with the ground. How high up the wall will the ladder reach? Pretty straightforward. So this is the opposite side, and we have the hypotenuse. So that means sine of 62 equals opposite over hypotenuse. 1 times x is x. Sine, or 15 times the sine of 62. Again, we're still working in degrees here, you guys. So 15 times the sine of 62 is 13.2 feet. Okay? All right, that brings us to the end of the notes for today. So, what you're going to do is with the rest of your time, you are going to work on your 4.3 assignment. Okay? I am sure there's also some of you out there who need to finish the 4.1 assignment. Please make the most out of the time you have here today. I cannot stress how important it is for you to stay caught up on this chapter, especially with me being gone today and Thursday. Friday is really going to be the day to get your questions answered. So if you don't try any of this, you won't know what questions to ask, and I won't be able to help you as much. So please make sure you're getting both of these assignments done. On Thursday, we're going to start taking a look at 4.4, and then we'll finish that Friday along with any questions that you had from these two lessons. Okay? All right, guys, feel free to, share books. If you forgot yours, use a Chromebook to access the online book, but really just please make sure you're being productive with your time. All right? I will be here during Flex today and tomorrow. If you want to come see me with any questions, please, please, please feel free to do so. Okay? All right, have a great day, guys. I'll talk to you later.